Okay, welcome back, Calc class. The only questions we had off of the two homework AP questions that I posted last time was from question 4 from 2015. So we're going to go through that one together, and then I'm going to give us kind of a breakdown of what I think we're going to do for the next little bit in this class. But let's start off with looking at this 2015 question, which is a differential equation question. It involves slope fields. Let's see what we can do with it. So the first part is label the slope field here at the points shown. So we have points at 0, -1, and we have to plug that into the equation, which is going to get us 0 minus -1, which is 1. So we have a slope of 1 there. We then have the point at 0, 1, which is getting us 0 minus 1. So a -1 slope there. And then the last one at 0, 2 is getting us the point, or the slope of -2, which is just a little bit more slanted down in the negative direction. Okay. Next, we're getting the points over here. 1, -1. That gets us 2 minus -1, which is 3. So we need a nice sharp uptick there at 3. 1, 1 gets us 2 minus 1, a slope of 1. And then 1, 2 gets us a slope of 2 minus 2, 0. And as we go through these, I'm going to give us the grade breakdown as they go. This is a 2-point question. They give you 1 point for this column, 1 point for this column of all correct slopes. You mess one of them up out of the 3 and you get no points. So they are kind of brutal with their grading, but this is not so bad to pull up 2 points here. Remember, these questions are all out of 9, so you got 2 9ths just for drawing a couple lines in. Not bad. Okay, part B says find the second derivative and determine the concavity of curve in quartile 2, or quadrant 2. This notation may be a little confusing, so hopefully everyone is okay with this notation, which means the first derivative. But then we've talked about this a little, but not a lot. Where this is really coming from is, remember to take the derivative. That's d dx. So we're taking this derivative, so the notation becomes a little weird here. There's 2 derivatives here of y, so that's why it's d squared y over, there's 2 different dx's, dx squared. This is our second derivative. Well, if they want us to find it, and it says that's the first thing, that's what we should do. The AP doesn't pull any punches. It says find it and then determine the concavity. So the first thing we should do is probably find out what this second derivative is. Well, think. The very top, if I can draw here, the only thing they gave us was the derivative here. And if we need the second, let's actually take the derivative of both sides. Remember, this is with respect to x, so that first term is just becoming a 2. The next term is the derivative of y, but since it's with respect to x, that becomes dy over dx. But since we knew what this was up top, we actually wrote it up here in the black. We can say that the second derivative here is the same as 2 minus 2x minus y, which if we really want to rewrite is 2 minus 2x plus y. And we have officially found the second derivative. However, it also says determine the concavity of the curve in the second quadrant. It also says explain. I probably should have written that. So let's think. If we're in quad 2, that means the x values in quadrant 2. That's over here. The x values are negative, and the y values are positive. And the equation for the second derivative we just found. So the 2 we know is always positive. This is always positive. The minus 2x, it's minus a negative, so this term is positive. And then we know that the y term is positive. So we have 3 positive numbers we're combining, which means our final answer will be positive. And if we have a positive second derivative, the second derivative is positive, then we are CU, concave up. So that's how we're going through this one. Even though we don't have any specific numbers, any part of the slope field here is going to be concave up. Or I guess any part of the original graph would be concave up in that second quadrant. Okay, next 2 parts. It says if y equals f of x is the particular solution with f of 2 equals 3, does f have a relative min or max or neither at x equals 2? Well, remember how we find a min or max? What we're thinking of here is we need to look at the first derivative and set it equal to 0. Well, first derivative, all right, they already gave us this one. Still that same initial equation that they wrote at the top. And we have this coordinate here. Remember, that's our x, that's our y. So putting this in here, 2 times 2 minus 3. Big brain math. We're left with 1. 1, let me compare it to 0. Yeah, they're not equal. So that's not going to be a min or a max. It would have to be equal to 0 to be a min or a max. So our answer here should be, it is neither. And you may be saying, well, what would have happened if it was 0? Would it be a min or max? And the answer is, we wouldn't know, because we don't have anything else to base it off of. So if it was 0, you could say it is either a min or a max, but we cannot determine which one it is. And let's look at the points at this. So you get 1 point for just plugging all this stuff in. I need a different color. And then 1 for writing neither. And I guess they needed a little bit more justification, since 1 does not equal 0, even though that's written there. Ooh, I should probably go back and tell you the points for this one. Not bad. They gave you 1 point for finding the actual second derivative, and 1 point for determining that it would be concave up with some reason. You can't just say concave up. You need to say it has a positive second derivative. Okay. So if you're keeping tally of scores, it was 2 points for the part A, 2 points for part B, 2 points for part C, 9 total points. That leaves us with 3 points here. Find the value of the constants m and b for which y equals mx plus b is the solution to the differential equation. Okay, so the only thing they really give us here is that we know, let's stay with the black one, y equals mx plus b. Okay, well, since this is calculus, let's take a derivative. That seems to be a good start, and see what we can get from here. Now the derivative of mx plus b, remember we're taking the derivative with respect to x. So let's look at that first term. Derivative of mx, that just leaves us with the m. And the derivative of b, that's some constant, that's going to leave us with 0. So we have that dy dx equals m. Going back to that same fact that we keep using at the top of this page, we know that the derivative of y with respect to x is still this expression, 2x minus y. Okay. At this point, we need to kind of figure out something here to find the values of these constants. Anything else we know here? Do we know what m is? Do we know what y is? Do we know what x is? Oh, right. They gave us this equation, y equals mx plus b. So in here, for the y, we can put mx plus b. Now, in trying to solve this, let's bring all the equations to the left-hand side. We have 2x minus mx minus b minus m would have to be 0. So I distributed that negative and I brought the m over. Let's look at some terms here in constants. So the x's go together because they're each that kind of variable goes with it, the x, and the negative goes with the b and the m. So think we have some term being multiplied by x, and it has to be 0. It's not like 5x over here. So what that means is that 2 minus m has to be 0, because we don't have any x terms over here for constants m and b. So that means that the m has to be 2. Okay, so when the m is 2, we know that this is 0. So we're just left with this. B plus m is 0. Negatives there, but that's not really affecting us. But we do know that b plus m has to be 0. But we just figured out that m was 2, which means that b has to be negative 2. And those would be the two constants that we're looking at. Okay, let's run down the point breakdown here. We get 1 point for just taking the derivative here and getting it here. And then you get 1 point for substituting this back in and having this equation written. And then finally 1 point for getting both correct answers to bring us to 9 total for the whole AP question. Okay, let's talk about what I want us doing moving forward. I think I'm going to start doing an every other day schedule. So giving you 4 AP questions to work on, give you that day, post questions the next day, and then I'm going to come up with a response video. So every other day, I'm going to be posting a response video. So what I want you to work on today, so that you can ask questions tomorrow, is, which one did I decide? Yeah. I want the 2012 AP. Questions 3 through 6, since they are the non-calculator one. I'm going to say give yourself approximately 1 hour, because that's how much time is slated for this. And then after that hour, look at the solutions, and then ask questions in the comments here. And I'll respond on, what's today, Tuesday? So Thursday, with answers to any of those questions, and we can go from there. Okay, guys, stay safe. Please go through this. Please keep working, and I'll talk to you all soon. Bye.